We're going to estimate the coordinates of each turning point and state whether it's a local minimum or a local maximum. So let me start on the left here. Let's see, I'm down here at 1, 2, 3. Ah, boy, how far are we going? 1, 2, 3. We're going. Looks like we're going by tens on the y-axis. To me, that's what it looks like. Looks like that's 10 right there. And we're going by ones on the x-axis. So looks like this first one is going to be negative 2 and a quarter, I'd say. And down here on the y-axis, 30, let's say 37, negative 37, because we're going by tens. And I would say that's a local minimum. Okay. And then let's see, this peak over here, which is just a little bit more than the lines they're next to, I would say that's negative 1 and let's just say fifth, I don't know. And it's a little bit up there, so let's just say it's just barely up there. So I'm going to say 1, positive 1, because the next line is 10. This is a local, and I mean local when I say max, but I'm going to say local max. That's a local maximum, mountaintop. This one actually looks like it might be on the line. I don't know. I'd hate to say that, but anyway, what would you say? A third? So we'll say 1/3, positive 1/3, and 1, 2, 3. Let's say negative 39. That's not quite to the line, is it? And this is a local max, sorry, it's a valley. But if I'm going to believe these arrowheads, I'm going to say it's probably an absolute minimum too. It looks like the very lowest point. So in my book, that's not just a local. That's also an absolute minimum, like the very smallest thing it could be. Where else is it going to be low? This is an even function. They're both going to positive infinity in the extremes. So I think this is as small as we get. So I don't just have to say local. This is one time when I don't have to say that. But I'm going to say it's a local minimum too, but it's also an absolute, I would say. Here we go with this maximum. And, well, that's a positive, what shall we say? 1 4/5. I love fifths, I guess. It's not 3/4, I know that. Maybe it's 7/8, I don't know. But then that looks like it could be on the level of 8. We have, each block is worth 10, so that's a local max right there. Certainly not an absolute. There is no absolute max. These things go up forever, you see. So there's no absolute maximum on this one. Over here, what shall we say? It looks to me like 1, 2, and let's say 2 2/3, 2 2/3. And it's a little bit more than negative 10, so I'm going to say negative 11. And this is a local minimum. Sorry for writing local every time, but I don't want to forget that when I'm talking about minimums and maximums, I'm usually talking about local instead of overall total dominance absolute. So we have 1, 2, 3, 4, 5 turning points. That's a lot of turning points, right? 5. So let me write that down. 5 turning points. And let's see. All real zeros. Well, what would you say? This looks like, what is that? 2 2/3. So my zeros are going to be negative 2 2/3, and of course y is 0. And then, oh, you know what? Let me erase that red dot because it kind of gets in the way of me seeing this. there are 2 here, because this thing goes above the x-axis. So there's 2 real close together here. We shall say negative 1, 1 and a third. And we'll also say, boy, that's tight. I guess we'll say negative 9 out of 10. It's so close to negative 1, but it's not. And we're estimating. It says estimate, so we're doing the best we can. Right here, that almost looks like halfway, doesn't it? I think that might be halfway. Let's say it is. 1.5 and 0. Of course, all these zeros are going to have y be 0. That's the point. Uh-oh, that's math humor. I'm sorry. That's awful. It's disgusting, that pun right there. We will say 2 1/4. And so there we go. There's our, we get 5? No, 6 zeros. Sorry, my apologies. I was going to leave this one out. I better not mark that up. What? I need to see that. Does that hit the line? I think that hits the... For all my stupid estimates, let's just go ahead and say that hits the line. 1, 2, 3. So that's 3, 0. Why was I going to leave out the nicest one? 1, 2, 3, 4, 5, 6. 6. The least degree of the function. Okay, I have 6 zeros. And I know that if I have 6 zeros, that's 6 is equal to n. My turning points are going to be n minus 1. Well, that's exactly what I have. I have 6 zeros, and I have 1 less turning point, just like the thing for my notebook said I would have. And so, you know, this actually does hit the x-axis in 6 places, and there's nowhere I could draw the x-axis. Like if I were going to draw it down here, there's no place I could draw it where it's going to hit more than 6 times. 6 is the maximum number. So I'm going to say this is a 6th degree polynomial. That is the smallest I could get away with. Of course, I could have some not irrational. I could have some imaginary roots to add to it, you know, if you want to add in some things. But the least degree possible is 6th degree. It could be 8th, it could be 10th, you know. Add in some more. We could add in x minus 2i, and then we'd have to say x plus 2i. And, you know, as far as we want to go, but we're interested in the least degree. So we're going to say 6th degree, since there are 6 real zeros and 5 turning points. They both feed into the idea that it's 6. Did we leave anything out? I don't believe so. Okay, there we go.